When it comes to the study of optics, one of the more foreign concepts can be the idea of real and virtual images. I mean, there's light that you can see and light that you can't see, right? We're going to dissect that a bit today. Let's take a look at our setup. We have our light source. We have several lenses. And we've got a wooden board that's going to act as a screen. Sometimes that can work better than white paper just because of the color. This is going to be holding the camera, and that's my dog. If this here is our light source, and this notebook is our screen, I'm going to use this lens to create an image of the light source on the screen. So if I take the lens, I put it in front of the light source, I get an image. A very clear image, actually. And so you can see that, and then it's just reflecting that light source. So this is what we call a real image. Now we're going to look at another type of image. We're going to be looking at that little octopus with another lens. Where we have the image of the octopus, this is different than what we had before. We can actually see the octopus, but one thing is it's flipped, but more importantly, it's on the same side as the octopus. His name is Ink. So the image of Ink is on the same side as Ink himself. This is called a virtual image. If you were to put a screen or a sheet of paper or a notebook or something at the point where we see this image, no light would actually be occurring, or no light would actually fall on the screen. Our brains just think that there is light there because they can be bad at things sometimes. This is a virtual image. Let's take a look now at why we get each of these types of images. To do this, we're going to do something called ray tracing. First thing that we do is we have this setup here. We have two of these setups. We have two lenses. These are unrelated to each other. This arrow here, that's our object. That's our object. You can think of that as the lamp or as the octopus. We then have this line here. It goes through the center of the lens. This is called the optical axis. We also have something called focal points. The idea of a focal point is that any light that passes through the focal point in any way emerges parallel from the lens. We'll see what that means in a minute. You can use this setup to find where you will see an image. To do that, we use 3 rays. All of these rays are going to start at the very top of the object. What we're going to do is we're going to take this ray. Our first ray is going to come parallel. It's going to go parallel until it hits the center of the lens. And then it's going to go right through the focal point. Our second light ray is going to go right from the top here. That's going to go, and it's going to pass through the middle of the lens and emerge on the other side. This last one is going to go through the focal point, or it should have. and it's going to emerge parallel. It's hard to do this accurately without a straight edge, but where all of these lines meet, let's say it's like there, because that red one was off, that is where we will see our image. The red one, you can see it didn't go through the focal point, so it's a little off, but you can see that they all should meet in the same place. This image is real. This is like the lamp. So this is the light bulb, this is the lens, and if you were to put a sheet of paper or a notebook here, you would actually see an image of that arrow. That's what happens when you have an object that is much further away than the focal length. This one that we're going to do, we're going to start by following the same rules. We're going to start at the top of the arrow. We're going to go parallel until it hits the center of the lens. And then it is going to go through the focal point. Next one is going to start at the top of the arrow. It's going to go through the center of the lens and emerge on the other side. Last one, it's going to be in line with this focal point in the top of the arrow. So it's going to go up until it hits the center, and then it is going to emerge parallel. If we look at this one, we see that this one looks different. With the last one, all of these rays met, or at least they should have met. With this one, they're all going in different directions. But our eye actually still sees an image. What you have to do is you have to trace each of these lines back. If you actually do this with a ruler, they should all come out to be in the exact same spot. In this case, we see our arrow here. That's our image. This is what we call a virtual image. This is what we saw with the octopus. With this kind of lens, if your object is within the focal length, then you'll see an image that's virtual.